Okay, so like I promised, we're going to talk about why the AAA and SSA criteria do not work to proving triangles congruent. So let's start with AAA. I'm going to draw a quick picture here. We have a big triangle, and we have a small triangle within it. Like so. Okay. And so I'm going to label the big triangle ABC. And I'm going to label the small triangle DBE. And we're going to state that DE is parallel to AC. Okay. So let me highlight the triangles. So we have this small triangle. Actually, let me do the big triangle first. We have the big triangle that I'm highlighting in blue. And we have the small triangle that I'm highlighting in yellow. You should notice that both the big and the small triangle share angle B in common. So angle B is congruent to itself by the reflexive property. Now, if we look at the two parallel lines cut by transversal AB, you should notice that this angle BDE and angle A are corresponding angles, so those are congruent by the corresponding angles postulate. Now, if we look at transversal BC, you should notice that angle BED and angle C are also corresponding angles, so those are congruent by the corresponding angles postulate. So we see that my small triangle, that's in yellow, and my big triangle, that's in blue, have three corresponding angles congruent. However, are these two triangles congruent? No, we can clearly see that my yellow triangle is smaller than my big triangle. So this picture describes or shows why the AAA criteria does not work. So we're going to write a quick explanation. As you can see in the figure to the left, the AAA criteria does not prove triangles congruent. Instead, what the AAA criteria does is it proves triangles similar. These two triangles, the yellow and the blue triangle, are similar triangles, which we'll learn about in our next unit. But it's not going to prove triangles congruent. Okay. So that's the AAA criteria. We're now going to move on to the SSA, the bad word backwards. We're going to show why this criteria does not prove triangles congruent. Bear with me on the picture. So I'm going to have you draw an isosceles looking triangle. That means that these two sides are congruent. Okay, off of this side here, I'm going to have you draw this in and then connect this side to that base here. Okay. So, I made it so this was an isosceles triangle here. Okay, we're going to be looking at two triangles. We're going to be looking at this big blue triangle and this smaller yellow triangle. And you should notice that blue and yellow triangle share this angle in common, and they share this side in common. So I'm going to label the vertices of the triangle. So my yellow triangle is going to be, my big triangle is going to be ABC. And my yellow triangle is going to be ABD. Okay, so we can see that on this yellow triangle and the big blue triangle, they have this angle in common, they have this side in common, and then these two sides are congruent. So by side, angle, these two triangles satisfied the SA criteria. However, is the blue triangle congruent to the yellow triangle? No. So we can clearly see that the SSA criteria does not necessarily prove triangles congruent just by looking at this figure. So an explanation could be, as you can see in the figure to the left, the SSA criteria does not prove triangles congruent. While the smaller and larger triangles share an angle and a side, and they have another pair of sides congruent, the triangles are not the same size. Now, SSA does not prove that the triangles are similar. When I say similar, is the sides are proportional. Here, the sides are not proportional. So SSA does not prove triangles similar, only AAA does. So keep that in mind. But this is why the SSA criteria does not work. Okay, so we're going to move on to more proofs. So sometimes our goal is not to prove two triangles congruent, but it's to prove corresponding angles or sides congruent. For example, if we look at number 28, we're not proving two triangles congruent, we're proving two corresponding angles congruent. So the process is the same. We're going to still prove the triangles congruent, but then we use something called, or the criteria, that corresponding parts of congruent triangles are congruent to prove that parts of triangles are congruent. So if we know that the triangles are congruent, then we know we're dealing with two congruent triangles, and so that would mean that the corresponding parts of those triangles are also congruent. Now, I'm not expecting you to write this in your proof. That is a very long statement, so there is a very fun abbreviation that we can use instead. CPCTC. All right, get practice with saying that really quickly. All right, let's get started with number 28. So our goal is to prove that these triangles are congruent first. So I'm going to say AB and DE are congruent, and BC and EC are congruent. That was just by what was given to us. So remember, we need three things congruent before we can state the triangles are congruent. We also were given that C is the midpoint of AD. If C is the midpoint of AD, that means that AC and DC are congruent, but we do need to state that in our proof, and that's by the definition of a midpoint. Now I have three parts on each of my triangles congruent to each other, so I can go ahead and say that these triangles are congruent, but I need to be careful of the order. If I say triangle ABC, then I need to say triangle DEC. That's the correct order, and that's by SSS. And then if I know that these two triangles are congruent, then I know corresponding parts of these congruent triangles are congruent. So angle BAC would then be congruent to angle EDC, and that is by corresponding parts of congruent triangles are congruent, or CPCTC. So that's my first proof. Moving on to my next one. I have my given, DB bisects angle ABC, and I know that AB is congruent to CB. So if I know that DB bisects angle ABC, that would mean that I know that angle ABD and angle CBD are congruent, but I do need to state that in my proof. That's the definition of an angle bisector. Also, if we look at these two triangles, they share side length DB in common. So I can say DB is congruent to itself by the reflexive property. Now that I said three parts are congruent in my proof on both of these triangles, I can say both of these triangles are congruent now. So I'm going to say triangle ABD. If I say that, then I need to say triangle CBD. So triangle ABD is congruent to triangle CBD by side, angle, side, because the angles in between the two sides that are congruent to each other. But that's not all. We're not going to stop there because we want to prove that angle BAD is congruent to angle BCD. Well, if I know these two triangles are congruent, I know that corresponding parts are congruent. So by CPCTC, the two angles are congruent. Now, if I asked you to say that the measures of these angles were equal, what you would do is you would add a sixth step, and you would say the measure of angle BAD is equal to the measure of angle BCD, and that would be by the definition of congruency. So sometimes we won't stop at CPCTC, sometimes we will keep going. CPCTC only proves parts of triangles congruent. It does not prove parts of triangles equal. It does not prove parallel lines. It does not prove anything except for parts of triangles being congruent to each other. All right, moving on to number 30, we're going to state our given. So there's three givens here. I have angle BCA is congruent to angle DCE. I also have that angle ABC is a right angle, and angle EDC is a right angle, and I have that BC is congruent to CD. Now, some of you may be thinking HL. However, we only have one side and one pair of angles congruent. We do not have the hypotenuse congruent, so we're not going to be using HL. Instead, we're going to be using ASA. But we do need to state that angle ABC and angle EDC are congruent. And how we can say that is we can say that by the right angle congruence theorem. Now that I have three parts of my triangle congruent to each other, I can say that these triangles are congruent. If I say triangle ABC, then I'm going to say triangle EDC. That's by ASA. And then BA and DE are congruent because corresponding parts of congruent triangles are congruent. So CPCTC. All right, we have reached our last one of this video. So we have a couple of pieces of information here. So we have that LM is perpendicular to JK. I have KN is perpendicular to JL. I also have JN and JM congruent. Okay. So from here, and maybe actually, since I'm dealing with JM and JN that way, I'm going to mark the right angles here. All right. So we should notice that KJL and KJL are congruent by the reflexive property. Let's start to mark our triangles. It looks like I'm dealing with this whole triangle, and I'm dealing with ASA in a moment, and I'm dealing with this triangle here. Same thing, ASA. So I need to state that my right angles are congruent, but first I need to state that they're right angles. So by the definition of perpendicular lines, angle JML and JNK are right angles, and then by the right angle congruence theorem, they are congruent. Then the triangles are congruent by ASA, and then I can say by CPCTC,